Hey everybody, how you doing? This is Claude. I'm here going to touch bases on. I'm going to do a quick lab to just do a high level demonstration of a simple topic in the BGP world. What you'll find out is in your career when you're dealing with BGP that you will probably do a lot of filtering. As you know, BGP is what runs the internet, and there's a lot of traffic, a lot of routes when you think about BGP to make this world move the way it moves. So, what I want to touch base on is basically I'm going to talk about communities at a high level. And in this case here, I'll be using communities as somewhat of a filtering mechanism. And basically, communities are nothing more than you can call it almost a label. And within that community, you can identify a specific network or a group of networks. Okay. And these communities can actually have certain attributes attached to them, which can change the way routers behave. From, like I said, from filtering to even using them for engineering route traffic in different directions. But in this here little example, I'm going to talk about what they call the standard, couple of what they call the standard communities, or you may hear the term in the industry, well known. Okay, so let me go ahead and go to all right, so here, what we have here in this here lab, we have this here simple topology here. And what you see are four ISR routers, autonomous system 104, which is designated here in the pink background. You have two routers, J3 and J2, that are in the same autonomous system 103. So that's going to be our iBGP setup. And then you have one more eBGP neighbor that sits out here as autonomous system 101. So just to give you a quick view of what we got here. We have this here router J4, which currently has 1, 2, 3, 4, 5, 6, 7, 8, roughly 8 networks on here. You can see them by the identified by the sub interfaces, as well as you got 3 different loopbacks on here. Okay, and just like I was saying earlier, you can see that these here are set up in BGP. All right, its next neighbor would be the 10 network, which would be J3, as you see here. Okay, and that would be this router that you see right here. So you see that neighborship is up. Okay, 10.4. And as you see, it's receiving non-prefixes from its neighbor up here in the pink. J4, J3 is receiving non-prefixes from J4, which I showed you were these here, the sub interfaces as well as the actual network itself. Okay. Now, like I said, communities is nothing more than you determining that you want to put a label on a specific prefix or prefixes, and there's something that you want done specifically to that entire group or groups. Okay, so as we take a quick look of these prefixes here, I actually selected 3 at random, And what you will find is, all right, so I have prefixes here that I label group 1 and group number 2. And within group 1, you can see that I've identified a specific network there, as well as here, the 5647 and the 56142. Okay. And I have on my second group, I have one of the loopbacks on this here router identified. Okay. Now with that prefix list, that identifies the networks that are in question that the action will be taken on. Like I said, so we got the 5647, 56142, and this here loopback 5602. Okay. So with that being said, those prefixes identify what I call the groups. I'm calling that group 1 and group 2 that contain them 3 prefixes. Now, the prefixes alone just won't do it. So what happens is you have to create route maps, and these route maps will actually point to these specific prefix lists, group 1, group 2. So when I go, I want to show the route maps that I created. And I actually labeled them J3 because that's the neighbor for this device. So what you see, route maps J3. All right, there's 3 statements in here, and these route maps are going to match the traffic coming from, you see here, group number 1, which I identified up top here, which contain these prefix entries, these routes here, and the second one was group 2, all right, which contains this here single loopback. Now, the third statement here is basically a permit everything else. So what I mean by that, if you think about how ACLs work, you have ACL statements, and at the very end of it of an ACL, you have what they call the implicit deny. Okay, you can almost consider the same thing when it involves route maps too. There's an implicit deny at the end of these here route maps that will be executed if you don't specifically put a statement in there to allow everything else to pass through. So just keep that in mind. Okay. Now, as you see, we've identified what prefixes are going to be utilized for the execution of these here route maps. Now here you'll see the set clauses. So here's where we actually attach a specific instruction where we utilize a standard community or otherwise a well-known community. Here we're going to do in no advertise. And basically what this one of the 4 well-known communities, the no advertise basically says that we do not want to advertise this particular route within the network, IBGP or either EBGP. We don't want to advertise it at all. Okay. And what happens is when the updates are sent in BGP, it's going to be sent. So it's going to come from J4, and then it's going to go into this IBGP neighbor here at J3. And J3 is going to read this information, and J3 is going to respect, okay, it's going to respect these here community clauses. And it's basically going to make a decision of if it's going to pass certain information on to J2 and so on. Okay, because ultimately what we want to do is we want to see this other autonomous system over here that's sitting out on the edge J1, autonomous system 0101. Okay, we want to see the ultimate results in there. And what I mean by the ultimate results, we don't want to see those three routes that we identified in group 1 and group 2 showing up in J1. So what you see here, I'll show the section for BGP. And what you'll see is the neighbor, okay, J4 will, that is connected to J3, okay, at 10.003, remote autonomous system 103, which is an IBGP. We see that we use the send community command, okay. Now, that send community command, there's a couple options that you got there. Right now, what you see is send community, but by default, it's going to send the standards, or what we like to call the well-known community attributes. You also have the ability to do extended, where you can actually get a little bit more customized in the type of community strings that you want to send across the network for whatever actions you want to take place. Now, like I said, with the send community, we also have to tell it, okay, neighbor 10.3, I want you to take a look and your instructions of what I want you to do is in route map J3, and I want you to do it outbound. Okay, so that basically means take a look at group 1 and group 2, and I want you to apply those clauses in an outbound fashion to the neighbor J3. Okay, so what we see here, we'll take a look at these here routes, and you see that this is what J4 has to offer. You see all these routes in here from 2.0, which goes all the way at the end, which will show up on J1. Down here at the very bottom, you'll see this here network here, this 85.0 network. Okay, so let's take a look at its neighbor J3. Like I said, we look at here. Let me guys show IP BGP, and what we see is pretty much identical. So this IBGP, okay, neighbor is getting these routes from J4. Okay, like I said, they're pretty much the same. Now, you see, like I said earlier, we identified 3 routes that we didn't want advertised. You'll see here that loopback address. You'll see this 5647 and this 56142. These were routes that we identified to not be advertised. Okay, but remember, in order for it to not be advertised, this here neighbor has to know up front which ones we want to show this extreme prejudice towards. Okay, so what we do is let's just check this, show IP BGP, and let's just pick one of these routes at random. Let's go 5620/29. Okay, and what you'll see is that this route is in the table. Okay, and it's coming from that is actually the loop back from J4, as you see here. That is the loop back from J4, which comes up as the router ID itself. Okay, and you know that from the old order of operations, where loopbacks set the precedence. You know, they get first choice as far as the sequence of how the router ID information is automatically filled in. So let's take a look at one of the routes that we actually have on this here community set list. So let's go, and we'll change this to one of the routes that's actually on that group. So we're going to go 56. We have that loopback dot 2 dot 10. Let me take that off. And what you'll see here is that J3 is respecting the instructions for the community tagging. Okay. And it's told specifically about this route not to advertise to any peer. Okay. Not to advertise from any peer. And you'll see here the community advertise. All right. So like I said, I'm going to show you this. Show IP BGP Community. Just so you can see again that we have 3 networks that we've identified that's within this community here that we want the routers to take action on. Okay. And as you see, this 5602 network is in that community itself. Okay. And we were told to not advertise it. All right. So J3 has an internal partner here, J2. So let's go ahead and take a look at router J2 and let's see what that says. All right, so we take a look at the routes that J3 has, and you can clearly see 56 dot, it's not there. It's not in the table. So therefore, what happens, J3, respecting the community instructions, does not advertise that route. And the same thing for the other routes that's in that same community string. So we're going to go 5647.3.0. It's not in that table. And the last one, 56142.7.0. It's not in the table. Now, just so that you'll see that other things are still going through, you see here in the BGP table, you see these other routes, like for example 85, which it learned. You see that I there that signifies it learned that from an internal neighbor. Okay, so let's show IBGP 85.0.10.0, and you see there that's going through like there's no problem, and that's being learned from 56.0.3.11, which is the router ID. That's a loopback for J3, and I'll show you that here. That's that loopback right there. So that's what that router ID is. Okay. And then, like I said, because the buck is getting stopped right here from advertising that, we can pretty much, it's safe to say that J1, the external BGP neighbor, is not getting that route neither. 56.2.10. It's not in the table. So that's what the community instructions of no advertise does for the network. It sends the instructions to its neighbors for whatever reason that you have to not advertise this prefix, this route, or routes, because you can have more than one identified through the network. Now what I want to do is I am actually going to change this, and we're going to watch the behavior change just a little bit. So what I want to take a look at is one of the other well-known attributes, which is called no export. Okay, and what I'm going to do is well, let me show you first, just in case, refresh your mind. Route map, show J3. Okay, so what I'm going to do is I'm going to destroy these here route maps, and I'm going to change the community instruction set from no advertise to another well-known community known as no export. So let me go ahead and destroy the J3 route maps. Okay. And then what I'm going to do is I'm going to rebuild these here route maps, but with a different community instruction, which will be the no export. Okay, now what you see here is this community set is going to be no export, which means ultimately, and since I got that rebuilt, let me do a soft clear so that BGP can, hold on. Okay, so basically what that does, that basically, instead of tearing down the neighborship, this does a soft reboot of the routes, which sends out brand new updates to the rest of the topology. Okay, so what the no export, as opposed to what we just came from, the no advertise, the no export basically says we can advertise the specific prefixes that were identified in the community, and like I showed earlier, group 1 and group 2, we can advertise them to an IBGP but not to another eBGP. So in essence, what it's saying is J4 can take those three those three prefixes, and it can propagate them through J3 and J2 here in Autonomous System 103. But guess what? J1 out here on the end, which is the eBGP, is going to get left out in the cold. So J1 will not show any sign of those three prefixes that we've identified. So again, show IBGP community. Well, not there, but here we go. Show IP BGP community. And like I said, what we got is we got these three that we've identified earlier with the route maps and with the prefix lists. Okay. And let's bring this back over to J2, which is the last neighbor before we exit this internal BGP system here. So what was not in the table before, we're just going to do a quick copy and paste. And what you see is that we do see it in J number 2. Because like I said, the instructions for this community is we can propagate it through internal BGP, but not to another external BGP neighbor. So, and as you see here, the instruction is clear: not advertised to eBGP peer. Okay, and like I said, we can see that it's an internal neighbor. All right, because another thing is it tells us that, you know, we got a local preference. Local preference is the mechanism that we utilize for traffic engineering when it comes to IBGP. And the community here, as we see, is no export. Okay, so when we go over to, and what you'll see, let me see, show IP BGP. When we look at the BGP table, all right, we see them here. the 5602. We also see the 56142 and the 56147. Like I said, internal BGP is free game for them to advertise. The real test is when we come over here to the external BGP neighbor, right? And what we want to see is pretty much the same thing. We want to see this not showing up in the table, which is what you see there. Okay. And actually, you will see, let me do this real quick. You don't see any of those that have been identified by this here community no export string showing up in this table. And just for good measure, you see one that's not on that list, 5620, that actually comes through. And that's comes through like it's supposed to. So the BGP table for that external neighbor has all the routes except for the 3 that we've identified. And like I said, that's just a high level of how two of the 4 standard communities work in the BGP world. Probably going to put together a lab and actually show the these same communities here set up in a different type of topology where a decision is made to force traffic one way or the other. So I'll be probably putting that lab together pretty soon and displaying that one as well. All right, like I said, this was a high level. Uh, BGP is a very robust protocol with a lot of stuff inside of it, and like I said, just one of those things where you just got to take your time, piece by piece, and just slowly build on top of what you currently have. And the thing is, not everybody uses communities in their networks, so it's definitely something that you just have to practice from time to time and just get the feel for it. Because literally in the real world, if you got communities doing the wrong things in wrong networks, you can create some serious problems for your client networks. All right, everybody, take care now. Talk to you later.